In this lesson, you will schedule the two DAGs that you've written previously to run automatically. One of the DAGs will run on a time-based schedule once every hour. The other DAG will run on a data-aware schedule as soon as new embeddings are ingested into the vector database. Let's go. Running DAGs manually from the Airflow UI is great when developing them and for ad hoc workflows. But most of the time, you want your pipelines to run automatically. If you imagine you work at a bookstore, new books will be added all the time, and you'd want the pipeline to run to create embeddings from descriptions of newly added books so your customers can find them. Scheduling pipelines is one of the core functions of Airflow, and there are many different options available to you. Before we update the DAGs, first make sure that the DAGs from the previous lesson are already in your Airflow UI. Since your lab environment resets after 120 minutes, there's a chance that the Airflow UI does not contain the DAGs fetch data and query data as shown in this UI. If this is the case, then make sure to pause the video and run the cells that are provided to you under section 5.2 in your notebook. You should then see these two DAGs in the Airflow UI. Make sure to trigger them before proceeding to the scheduling section. Also, for this lesson, you don't need to worry about my first DAG and my second DAG. We'll go over the two most common types of schedules, cron-based and data-aware. You could find a link to a guide covering all scheduling options in the resources section at the end of this notebook. In Airflow, you can schedule each DAG by adding DAG parameters to the Add DAG decorator. Let's schedule the DAG that fetches the book data to run automatically at the top of every hour. To do so, you need to add the schedule argument to the Add DAG decorator and set it to the cron string for 1 hour, which is 0, followed by 4 stars. Or you can use the Airflow shorthand for this cron string, which is @hourly. You also need to give your DAG a start date. After this date, the DAG can run based on its schedule. Always make sure your DAG's start date is in the past. After running the cell to save the change to the DAGs folder, you can see the schedule displayed in the Airflow UI, both in the DAGs list and on the individual DAG. Note that a change of the DAG schedule is a structural DAG change, and therefore creates a new DAG version. Now, as long as the DAG is unpaused, that is, the blue toggle is set to on, it will automatically run at the top of every hour. Time-based schedules are very useful, but often you don't know exactly when you want the DAG to run, just that it should run based on the right data being ready. In our case, let's make sure the query data DAG runs as soon as the embeddings are loaded to the vector database. This is where data-aware schedules based on Airflow assets come in handy. An asset in Airflow is an object that represents a real or abstract data object anywhere in your pipeline. It can represent a file in cloud storage, a table in a relational database, or, in our case, a whole collection in VB8. You, as the DAG author, decide which tasks update which assets by assigning them to the task's outlets parameter. The task does not actually need to interact with the underlying data object, but in this example, it does. Whenever this task completes successfully, an asset event will be created for the asset. The asset has been updated. A downstream DAG, in your case query data, can be scheduled on one or more assets having received a new asset event. You could think of assets like little flags that you give your tasks to wave once they finish successfully, and a data-aware schedule like telling a DAG to wait for the right combination of flags to have been raised. Let's give the last task in the fetch data DAG an asset to update. You can add assets using the outlet's task parameter. This parameter is available in any task, including traditional Airflow operators. Set the outlets parameter to a list of assets that this task updates. In your case, the task loads embeddings to Viviate. Let's call this asset MyBookVectorData. Looking at the DAG graph in the Airflow UI, you can see the assets your DAG is connected to by opening the Options menu and selecting External Conditions in the Dependencies field. The Load Embeddings to VectorDB task in the Fetch Data DAG now updates the MyBookVectorData asset. Great! Now let's schedule the Query Data DAG based on updates to this asset. In the addDAG decorator of the Query Data DAG, add the schedule argument and set it to the asset this DAG should be waiting for. Make sure that you use the exact same name, MyBookVectorData, as in the asset added to the Fetch Data DAG. The name is used to identify the asset and connect the upstream DAG, which updates it, to the downstream DAG scheduled on it. This connection is visible in the Airflow UI. If you click on the Assets button, you can see the MyBookVectorData asset in the Assets list. Click on it to open the asset graph. It shows all the DAGs this asset is connected to. From this view, you can pause and unpause the DAGs and navigate directly to the associated DAGs by clicking on their name. You can also manually create an asset event using the blue button in the top right corner of the screen. The two options available are Materialize, triggering the DAG upstream of the asset to run, and, if the Load Embeddings to VectorDB task is successful, create an asset event, or Manual, which just creates the asset event that causes the downstream DAG to run. The latter option is very useful when developing to test your asset schedules. Note that asset events can also be created from outside of Airflow using the Airflow REST API. Nice! Your two DAGs are now linked together through a data-aware dependency. When writing complex Airflow pipelines, it is common to have many DAGs linked by many assets so that they all run as soon as the relevant data has been updated, like dominoes. There are many more DAG parameters other than schedule you can use to modify the behavior of your DAGs. You can find a link to a full list in the Resources section. One more DAG parameter that is useful for your Query Data DAG is the params parameter. It allows you to modify the form shown when manually triggering a DAG to ask for a specific input. Let's use this parameter to allow our users to input a different value for the query string parameter whenever they manually run the DAG in the Airflow UI. In the addDAG decorator, you can add params as a parameter and set it to the dictionary of params, where you include a default value for each input. When running the DAG manually, your users will be able to override this default value. The values from your params dictionary are stored in the Airflow context, a dictionary containing information about your Airflow DAG run that can be accessed inside of Airflow tasks. To access the context, put **context in the definition of your Airflow task. In your case, this will replace the query string argument, but the Airflow context can also be used alongside any number of task arguments. Inside the task function, use the params key on the context variable and index into it with your param name, in this case, query string. The value for query string is then used by the rest of the task to perform the near vector search. Make sure to also remove the hard-coded value for query string from the task call. After saving the changes, the Airflow UI now displays a field for the query string when manually running the DAG. I think I want to read a book about sleep. Let's use that as an input. Checking the logs of the DAG run, You can see that the task now recommends a different book about lucid dreaming. Perfect. If you want to add your own book file for this lesson with book descriptions to query against, run the helper cell. Awesome! Your DAGs are now scheduled, and your query data DAG includes a handy option for users to query for different books from the Airflow UI. The DAGs are almost ready for production. In the next lesson, we'll focus on how to parallelize this pipeline even more to make it more efficient and easier to troubleshoot.